In this tutorial, we are going to talk about vectors. So I've got three interesting questions under vectors which we have to solve. So the first question is two children, A and B, push a block. If A pushes the block southward with the force of 40 or 400 Newton, at the same time, B pushes the block eastward with the force of 300 Newton. Then determine the resultant of force A and B. Okay. Now, when it comes for vectors, the basic idea behind vectors is to know how to resolve the vector into x and y component. The moment you know how to resolve the vector into x and y component, and you also know how to get the angle, that is very, very important. Once you know those two, then you are done. So in this case, we have got two children. They are pushing a what? A block. So let's say here is our block. Okay, this is my block. The first one is block. They're saying that if A pushes the block southward, meaning this person is pushing this block southward, is going toward the negative y axis, that is A. So this has got 400 Newton. Then B pushes eastward. Eastward is going that direction, which is 300 Newton. So if I'm to get this, I can clearly see that we have something like this. Okay, meaning the resultant vector is from this point to that point, which is going to be there. That is our resultant. This is A, okay, and that is our B. So our B is 300, our A is what? Is 400. Now to find the resultant, we can clearly see that here we can use Pythagoras theorem to find the resultant. So this is just direct. There is no debate about this. So to find the resultant vector, it will be the square root of A squared plus B squared. Since it is following the Pythagoras theorem, that's the reason why there is no need of us resolving this vector into x and y component. So I'll have A is 400 squared, 300 squared. So if I get the answer, I square root it, I'll have 500 newtons as my resultant vector. At the same time, if you want to follow the principle of how to resolve a vector into x and y component, we'll be able to find the same answer at the same time. Okay, so the next question is, a person walks 55.0 meters at an angle of 47 degrees north of east. These are very important terms which we have to know under vectors. What does the word north of east mean? North of east meaning the angle is near east than north. So if you have north of east, meaning the angle is near this than north. So now I'll first have to come up with an xy plane. If this happened to be my xy plane, the first one is telling us that north, a person walks 57 meters at an angle or at 47.0 north of east. But at the same time, I'm from telling you to say north of east, what it means is the angle is near east than north, meaning that this angle here, the angle in between is 45. So this statement is not making sense here. Initially the angle was supposed to be less than 45, because if we say north of east, that angle has to be near east than, so I have got this is north, this is south, this is east, and this is west. This statement is not making sense because 47 in between north and east, if you have been given a statement which is saying you have got an angle north, or you have got a vector which is lying northeast, just northeast, not north of east but northeast, if it is like that. North, east, meaning the angle is in between north and east. In that case, it is 45. But this case, north of east, the angle is near east than north. So this statement is not making sense because this angle is 47. 47 is greater than 45. So it's not making sense at all. But anyway, let's just follow it. So the angle, this angle 47, I'm going to put it here. It is telling me that it is near north, or it's near east than north. So that angle is here, which is 47 degrees. Then they are saying turns and walk 72 meters at 15 degrees south of east. South of east meaning the angle is near east than south. So this is south. So the angle should be near east than south. Okay? So this is 57 meters. Now this is 72 meters. So that angle which is near east is 15 degrees, is here. But when resolving this vector, I need to get the angle from positive x-axis all the way to where the vector is. Meaning for this one, the one for 72.0 meters, the angle which I'm supposed to use, I'm going to say 360 minus 15, which is 345. And then turns and walk 24 meters 30 degrees west of north. West of north meaning the angle is near north, or the angle is near north than west. So I'll have it here. The angle is near north than west is there. I'll put that one to be 24 meters. The angle, the third one is there. But remember, when resolving this vector, we need to get the angle from positive x-axis all the way to where the vector is. So I'm going to say 90. So for 24, it's going to be 90 plus 30. So 90 plus 30 is 120. So I'll say this, I'll use 120 degrees. Now I need to resolve each vector into x and y component and solve the angle. Now the best thing here to do is resolve each vector into x and y component. Allow me to denote this one to be vector A, this one to be vector B, and that one to be vector C. Therefore, to find the x component, I'll say ax will be equal to a cos theta. So my ax will be equal to a, the vector is 57, because the angle here, since the angle is in the first quadrant, we'll use the same 47. So ax will be equal to 57 cos 47, which is 38.87. 38.87. I can just say it's 38.9. Okay, now let's resolve this in y. So it's going to be a sin theta. A is 57 sin 47. AY will be equal to 57 sin 47, which is 41.687, which is the same as 41.7. I'm done with A. I can go now to B. So B, x will be equal to B cos theta. Bx will be equal to my B in this case. My B in this case is what? Is 72. The angle is 345. That's what we have said. So my Bx will be 72 cos 345. It's giving me 65, sorry, 69.5. I'm done with B. Then to find By is going to be B sin theta. By will be equal to my B is 72 sin 345 So my by will be 72 sine 45, or 72 sine 345. This is giving me negative 18.63, which is just 6. I also have to resolve c in x and y component, so I'll do it from here. Cx will be equal to c cos theta. Cx will be equal to, my c is 24 cos, my theta is 120. So my Cx will be equal to 24 cos 120. It's giving me negative 12. Okay, I leave it there. Next, I'll go to for Cy in y component. C sine theta. Cy will be equal to, my C is 24. Sine the angle is 120 degrees. So Cy will be 120 sine 24, sorry, 24 sine 120. This is giving me 20.78, which is 20.8. Now the question is, if we get it from here, now I no longer need this. Oh, not really. I no longer need this diagram here. Let me just remove it. So what I'm going to do now, I have to write, I have resolved this into x and y component. So I need to add all the x components alone. So the question is, how far and at what angle is the person's final position from his or her initial position? That is the resultant. They're asking about the resultant. To find the resultant, you say the resultant in x-axis is going to be, ax plus bx plus cx. Okay, so ax we have found 38.9, bx is 69.5, cx is negative 12, like that. My rx will be equal to 38.9 plus 69.5 minus 12. So this is giving me 96.4. We leave it here. Then I need to go now in y. I can now get rid of this. I'll say my ry will be the result of ay plus by plus cy. So ry will be equal to, ay is 41.7, by is negative 18.6, plus cy is 20.8. My ry will be 41.7 minus 18.6 plus 20.8, like that. So I'm getting 43.9. Now that I have the x and y component, the next thing I can do is, I now use the formula which we use to find the resultant of, or the magnitude of the resultant. To find the magnitude of the resultant, we'll say the resultant, I put an r on top to show that that is a vector we're talking about. It will be the square root of rx squared plus ry squared. So if we plug in the values, I have 96.4 squared plus 43.9 squared. I expect my resultant to be, so 96.4 squared plus 43.9 squared. Okay, so I get the square root of this. I'm getting my answer to be 105.9. So 105.925 to in meters. Now if I round it off, you can see that our answer here, it was showing that the answer should be 106. So we just round it off and say the resultant is 105 point, oh, I round it off, it's going to be 106, like that. Now another question is we need to find the direction. To find the direction, first identify the x and y component. Okay, so if the x component is positive, the y component is also positive. When finding the direction, we use the formula theta to be equal to tan inverse the y component divided by the x component. In this case, we know that if the x component is positive, the y component is negative. I'll have my xy plane here. This is the first quadrant, the second quadrant, the third quadrant, the fourth quadrant. If the x component is positive, the y component is also positive. The angle falls in the first quadrant. In the first quadrant, that's where we can see that this is positive y, positive x, negative y, negative x. So in the first quadrant, that's why we can see that x should be positive and y should be positive. So when you find the answer using this formula, the theta you find, that is your answer. You leave it there, that is your direction. If you discover to say the x component is negative, the y is positive, meaning it is in the second quadrant. In the second quadrant, y is positive, x is negative. Then when you plug in the values here using this formula, you find the theta. To get the actual angle we are looking for is you say 180 minus the theta you're going to find, provided that the x and the y component here, you just plug in positive values only, ignore about the negative, and follow these simple principles. The next thing we have to know is that if the x component is if the x component is positive, or let's say negative, the y is also negative, then the angle falls in the second quadrant here. In the second quadrant, what you do is you plug in only positive values in this formula. Then you say the answer you're going to find, you say 180 plus the theta you are going to find using this formula. Okay, the next thing is if x is negative or positive, y is negative, then it is in the fourth quadrant. In the fourth quadrant, when you find the values here, provided that you have plugged in positive values only, you say 360 minus the theta, meaning that is the angle we are looking for. In this case now, we want to find the direction. What are we going to do? Let's check first the x and y component. Our x component is positive, our y component is also positive. Definitely it has to fall in the first quadrant. In the first quadrant, when I plug in the values using this formula, the answer I'm going to find, that is my answer. Okay, so I'm going to say the ry divided by rx. Theta will be equal to tan inverse. My ry in this case is 43.9. My rx is 96.4. So theta will be equal to, if I get my calculator, shift tan open brackets 43.9 divided by 96.4. So the answer I'm getting is 24.48. Okay, 24.48 degrees is my angle in this case. If I want, I can just say my angle is 24.5 degrees. As simple as that. So this is how you work out this type of vector problem. Okay, so I have another question which is saying we have the diagram, and then the question is find the resultant, which is the net force in this case. How do we find the resultant? In this case, to find the resultant is just to resolve each vector. We have been given the vector, each vector into x and y component. The best thing to do, if you don't want to make any mistake, denote this vector to be this to be a, this to be b, this one to be c, and this one to be d. Then resolve each vector into x and y component. Okay. Now, the best thing here to do is we want to find the net force, which is the resultant, and you know that the resultant is going to be a result of a x plus bx plus cx plus dx, like that. And you know that in x component is supposed to be cos theta. So I'll say rx will be a cos theta, plus b is going to be b cos theta, plus c will be c cos theta, d will also be d cos theta, like that. Now we need to understand here. I'll start with a. A is 80 in this case. Now, which angle are we going to use? This is going toward positive x-axis. The angle is 0 degrees plus. My b is 100. Then I have cos. The theta which I'm going to use, we are measuring the angle from positive x-axis from there until where the vector is. So the angle is 45. Plus my c is 110. Which angle am I going to use? We are getting the angle from positive x-axis until it touches the vector. Now at that point is going to be, since we know that from this point all the way to that point is 180, since we've got 30 here, we're going to say 180 minus 30, which is 150, meaning my angle here is 150, plus my d is 160. 160 cos. The angle I'm going to use is supposed to come from positive x-axis until where the vector is. So this point all the way until where the vector is. So 180 plus 20, which is 200. So the angle there is 200 degrees. Okay, meaning my rx will be, I'll just do it direct. I'll say 80 cos 0 plus 100 cos 45 plus 110 cos 150 plus 160 cos 160 cos 200. So here I'm getting negative 94.9, which is just the same as negative 95 Newton as my rx. To find the ry, I'll do the same. Ry will be as a result of ay plus by plus cy plus dy. So my ry will be equal to my a. In this case, we know already it's not going to change. It's 80 sine. In y we use sine 0 degrees, plus in b is 100. B is 100. Then sine the angle. I'm just following here the angles which I have here. Okay, sine the angle 45 plus 110 sine the angle which I have is 150 degrees, plus again here I'm going to say 160 sine the angle which I have there is 200. So I'm going to do it direct. So it's going to be 80 sine 0 plus 100 sine 45 plus 110 sine 150 plus 160 sine 200. So I'm getting 70.98, which is the same as 71 newtons. Now that I have my rx to be negative 95 and I also have ry to be 71, I can find the resultant. To find the resultant, we know that we are supposed to say the resultant, you put an r on top, the square root of rx squared plus ry squared. My resultant will be equal to the square root of my ry is negative 995. Now I square it plus 71 squared, like that. So if I say I ignore the negative because it's squared, so negative will go. So it's 95 squared plus 71 squared. I get the answer. I'm getting 14,066. The square root of this is 118.6. 118.6 newtons. I round it off from the answer which you have here, meaning it is 119. Okay. The next thing we have to understand is that I want to find the direction. The direction is given by tan theta inverse ry divided by rx. Okay. Now, the previous question I explained to say if x is negative, we can see that rx is negative, the ry is positive. From our xy plane here, this is the positive x, negative, or positive y, negative x, like that. So if x is negative is this line, y is positive is there. So meaning we expect this to be in the second quadrant. What do you do in the second quadrant? What do you do in the second quadrant? In the second quadrant, when I plug in the values here, remember I said I ignore the negative. So if I ignore the negative, it's going to be if I ignore the negative here, I can clearly see that my ry is going to be 71. My rx is 95. I'm ignoring the negative. When I ignore the negative, since it is in the second quadrant, I'm going to say the answer I'm going to find, I'll say 180 minus the theta I'm going to find here. So my theta in this case will be equal to, I'll say shift tan, open brackets, 71 divided by 95. Okay. So the answer I'm getting right now is 36.77, which is the same as the theta to be 37 degrees. Now, to get the answer, this answer which I've gotten here is from negative x-axis. That's why here is saying negative x-axis. From negative x-axis, the answer is 37 degrees. What do we mean? If this is my x-axis, positive x, this is negative x. I know that this is the resultant which you have. The angle here is 37. So from negative x-axis is 37 degrees. But if you want, this is the answer. 37 degrees is also the answer. So you say 37 degrees from negative x-axis. Don't just say 37 degrees, no. Then when you want to say the answer from positive x-axis, you will say 37, you say 180 minus 37. The answer is going to be 143 degrees. Now this 143 is from positive x-axis. So there are two things. You can say the resultant is 119 Newton at an angle of 37 degrees from negative x-axis. The answer which we have been given here is from negative x-axis. Another answer you can say 119 Newton at an angle of 143 degrees from positive x-axis. That is very, very important. Okay? So the most important thing which you have to understand under vectors is how to get the angle and how are you going to present the answer. So you can present the angle in two ways, either from negative x-axis or from positive x-axis. You can either use clockwise or anti-clockwise. Anyway, so another answer you can say, you can simply say, okay, like in this case, let's just stick to negative x and positive x-axis. So you need to know how to present your answer. That is very, very important under vectors. And also you need to know how to resolve each vector into x and y component, and how to get the angle which you are going to use when resolving the vector. Okay, so that's what you need to know under vectors.